2002. It is asked in your GATE 2002. Okay, sorry, 2007. 2007. So the question is exponents exponentiation is a heavily used, okay, operation in public key cryptography. So in cryptography you are using, okay, which of the following option is tightest upper bound on the number of multiplication required to compute b to the power n mod n? Okay, so they are asking which of the following option is the tightest upper bound, is the tightest upper bound. Okay, that is going to be go on the number of multiplication required to compute this. So to compute this, what is going to be the maximum number of tightest upper bound, okay, on the number of multiplication to compute this, and b is greater than equal to 0 and n is smaller than equal to m. A is the correct one. So by using binary exponentiation, that so we can reduce the number of multiplication. Okay, we can reduce the number of multiplication. So those who have missed that, let me, for that I am giving you just a small brief of that. Okay, so what you can do, you can use brute force method. If you use brute force method, you have to do the all the multiplication. Yes, first by using brute force, what we can do, we can do, so you can write the notes. We can do first b to the power n, as b to the power n is equal to b into b into b into b into b till this. So it require n minus 1 multiplication. So it require n minus 1 multiplication in brute force. So it requires n minus 1 multiplication to compute b to the power n, to compute b to the power n. So this method, this method require how much time? Big of n minus 1. But we write write b to the power n as b into b into b into like this. It is there. Then assume, see this, then assume b into b, this b into b as c, then assume c equal to b into b. So we can reduce it. If you're done with the writing, then you can let me know. So by this we can reduce the number of multiplication. Only once we are going to do b into b c. So wherever you will get this b into b, you will write c. So one multiplication like this. I have shown you this thing, okay. So this time I am going to show you by the time complexity, by the recurrence relation. Okay, previously by using the options we have eliminated. Now this time by using the recurrence, and by using the recurrence we will find the time complexity. Okay, is it done? Are you done with the writing? Please let me know. Fine. So it will be c into c into c into, like this it will go till c. Now similarly d, assume d as, assume d equal to c into c. So then b to the power n is going to d into d into d. Like this it will go till. So here every time, every time we are, reducing. So every time we are reducing tn problem as tn by 2. I am reducing tn problem as tn by 2. So the time complexity is going to be tn by t n by 2 plus 1. Tn by 2 plus 1. So this plus 1, why? For mod operation. This plus 1, the constant time we are requiring by this for this one. After this we are going to do mod. See, after b to the power n, see they have said b to the power n, then mod m. So this plus 1 is for, this plus 1 is for mod operation. For constant time we require for mod operation. So now if you will solve by using the your master theorem, you will get, so here you can write here a is equal to your 1 which is greater than 1, greater than equal to 1, b is equal to 2 which is greater than 1, k is equal to 0 and p is equal to 0. Now if you're done with the writing, then you can let me know. Now we will compare. See, understood now the recurrence? We are dividing every time the size of the problem by half, and this plus 1, this plus 1 the constant time we are requiring for the mod operation. Is it done? If you're done with the writing, then please let me know. Anyone having any doubt, then also you can tell me. Then compare a and b to the power k. A is your 1, b is your 2, k is your 0, it's equal, it's going to 1, and p is greater than minus 1, p is greater than minus 1, then tn is going to your, then this case tn is going to your theta into the power log a b log p plus 1 n. So theta into the power log a is your 1, b is your 2, log p is your 0, 1, 0 plus 1. So this is going to your 0, theta n to the power 0, and then this is going to log 1 n. So this is going to your 1, so theta log n. That's why always we are getting time complexity as log of n. So whenever they will ask you to reduce the number of multiplication, the worst case is going to your big of log n. Okay.